And back to our exciting message. Here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to be reviewing for the test that's later on today. I want to start out by looking at a couple of problems that people emailed me. So we'll do that first. This one comes from section 5.6, number 15. It says to multiply and then simplify your answer completely. So it says multiply, and we are multiplying together three binomials, x plus 8 times x minus 5 times x minus 3. The thing we need to remember is that we can only multiply two things together at once. So I'm going to start out by multiplying together the first two binomials. I will FOIL them together. X times x is x squared. X times minus 5 is minus 5x. 8 times x is 8x. 8 times minus 5 or negative 5 is minus 40. Combining like terms, we get x squared plus 3x minus 40. We're now going to take that resulting trinomial and multiply it by the final binomial. So now we've got x squared times x is x cubed. X squared times minus 3 is minus 3x squared. Moving on, 3x times x is plus 3x squared. 3x times minus 3 is minus 9x. Moving on, minus 40 times x is minus 40x. And minus 40 times minus 3 is plus 120. Combining like terms, we get x cubed, those would cancel, minus 49x, and then plus 120. So there's the final answer. Any questions about that problem before we go on to another example? All right, give me just a minute here to find the other question that somebody asked. Let's see here. Okay. Yeah. All right. This is from the Chapter 5 review, problem number 20. And what we have is a polynomial. Oh, the directions say divide. Do not use negative exponents in the answer. And we have the following division problem. 10 a to the 5th b plus ab squared minus 4b all over 2a squared b. So we have a polynomial divided by a monomial. The first step is to rewrite the problem, taking each term in the numerator divided by the monomial term in the denominator. Okay. Now, next we go back and we reduce each fraction. 10 over 2 is 5. A to the 5th over a squared is a cubed. And b over b is just 1. So we end up with 5a cubed. All right. Plus the next term, a over a squared gives us a to the negative 1 on top, which would become a to the positive 1 on the bottom. B squared over b would give us a positive b on top. So we get plus b over 2a. And then minus 4 over 2 is 2 over 1. A squared on the bottom stays a squared on the bottom. B over b is just a 1. So we end up with minus 2 over a squared. All right, and that is the correct answer. Now, I'm not sure why WebAssign does this. And a lot of you probably did something like this, but it isn't really what we talked about. So technically it's incorrect. WebAssign did this, okay? The student that requested this had this problem. And I'm not sure how they went about this, but they basically took out the fact that there's a b on top and a b on the bottom. And so they wrote 10a to the 5th plus ab minus 4 all over 2a squared. And the process of getting there was never discussed in this class. The WebAssign marked this correct. These are equivalent, but it's not what we talked about and how we went about doing it. So as far as I'm concerned, it's an incorrect answer. WebAssign is marking it right, so I would give credit for it, but it's not the correct procedure. This is the correct procedure. Okay, any questions about that one? All right, then let's open it up for any specific questions you have. And then after that, I'll just do some highlight review things as we go. So any specific questions from any of you there?
What about number 9 on the review?
Number 9 on the review. Okay. Do you want me to bring it up or do you want to just tell me what it is? It's your choice.
No, you can bring it up. Like,
okay. Let's see here. All right, Sarah, let's see which class you're in. This one. Okay. So this is the review. And you said number 9, right?
yes.
Okay. So this is the chapter review number 9. It says multiply, simplify your answer completely. And here's the problem. It's negative a squared b squared times the quantity negative a to the 4th b squared plus a cubed b cubed minus a b to the 4th plus 9a. All right, let's take a look at it here. Just so here it is in WebAssign. Okay, so we've got this problem number 9. All right, it says simplify your answer completely. So we're going to distribute. Negative times negative would be positive. A squared times a to the 4th would be a to the 6th power. B squared times b squared would be b to the 4th power. Then we're going to take negative a squared b squared times a positive a cubed b cubed. Negative times positive is negative. A squared times a cubed is a to the 5th power. B squared times b cubed is b to the 5th power. Then we're going to distribute negative a squared b squared times minus a b to the 4th. Negative times negative is positive. a squared times a to the first power is a to the third power. Even though there's no exponent written here, there's an implied one, okay? B squared times b to the fourth is b to the sixth power. And then negative a squared b squared times a plus 9a would be minus 9a cubed b squared. None of these final terms are like terms with any others there. So there's your final answer. And you could put those terms in any order you wanted. So, but it should still be correct. All right, are we okay with that one?
Yes.
Anybody else, any questions about this particular example?
Yeah, I had one on the review, number 18.
Hang on. You didn't hear my question. I said, anybody have any questions about this particular example?
Oh, sorry about that.
Sorry. Okay, go ahead. You have one on the review.
Number 18.
Okay. Give me a second here to find it. Let's see. And you said on the review. Okay. It looks like you got them all right, but which one is it that you wanted to look at? Alana? Yoo-hoo.
Sorry about that. I thought I was unmuted.
Okay, which one?
Yeah, number 18, because I was getting the signs wrong at first, so I'm not sure like how to apply the negative.
Okay, good. Let's take a look at that one. So here is the problem in WebAssign. Okay, so number 18. So notice you've got a negative sign outside of a grouping symbol, and the grouping symbol is squared. Okay, yeah, this can be a tricky one. So let's see, let me get this problem copied down. So this is, was this the chapter review? Yeah.
Yes.
Okay, chapter review number 18. We have negative the quantity 8a minus 3c squared. Okay, let's go back to the whiteboard. All right, before we do that problem, I actually want to look at a different problem. Let's just take a look at this problem. Okay, and in fact, we'll go ahead and do this. So order of operations, you would do the exponent before the subtraction. So this would be 2 times 2 times 2, which is 8, and then you would attach the negative sign. Okay, that's not too bad, but here things get a little bit more complicated. Basically, what we've got is 8a minus 3c times 8a minus 3c, but at the end, there's this negative sign attached. Okay, now here we have a couple of choices. We could take this sign and we could distribute it to the first group, and then take the result and just multiply that by the second parentheses. Or we could multiply the two parentheses together, because technically we should do the multiplication first. And I'm going to do that second one. Okay, so now I want to undo my negatives. So I'm going to do this first. Okay, so that's going to be 64a squared minus 24ac minus 24ac plus 9c squared. Okay, but I'm going to combine like terms, so I'm going to get 64a squared minus 48ac plus 9c squared. But now, after we've multiplied the stuff, we're going to apply that negative sign. But the negative sign is outside the entire group. So we need to distribute that to each term inside, which gives me negative 64a squared plus 48ac minus 9c squared. So there's your final answer. You okay with that, Alana?
Yes, thank you.
Anybody questions on this specific example? All right, something else, anybody?
Yeah, I have a question.
Okay, Jamie, what do you got?
Let me find it really quick.
Okay,
So I was struggling with, I think it was the 5.8 part 2 homework last night.
okay.
Is that okay, or did you just want questions
No.
on the review?
Anything.
Okay.
You can ask me what I had for breakfast if you want. I'm here for.
Okay, so I think it was number 5 and number 8.
On which section?
For the same reasons.
Sorry, for the what section?
Maybe number 5 and number 8 on the second part of the homework for 5.8.
Okay, 5.8 part 2. Got it. Okay, yes, I see there. 5 and 8. Okay. Let's see here. So this is 5.8 part 2, and this is problem number 5. It says perform the division. We've got 5x minus 2 on the outside and 23x minus 10 plus 15x cubed minus x squared. Okay, well, right away I can see the first thing we need to do is take the dividend, the stuff inside, and put it in descending or standard form order. So we're going to rewrite that with a 5x minus 2 outside, and inside we're going to have 15x cubed minus x squared plus 23x minus 10. Also note there's no missing terms, so we don't have to put any zeros in there. Okay so far?
Yes.
All right. So now we're going to take the leading term inside divided by the leading term outside. 15x cubed divided by 5x. That's going to give us 3x squared. Okay.
Yep.
Then we're going to take the 3x squared times the divisor, that is the 5x minus 2, and we get 15x cubed minus 6x squared. We're going to take that quantity and write it up here. Then we're going to subtract that quantity from what's up above. We'll change it to addition of the opposite by distributing. 15x cubed plus negative 15x cubed is 0. Negative x squared plus positive 6x squared is 5x squared. Bring down the next term, the 23x. Okay. Now we're going to start all over. And if I'm going too fast, you need me to stop or wait, please yell. I'm happy to slow it down. I'm not going anywhere.
No, I think you're okay. I have weird random numbers on my page. I don't know where I got them from, but I agree with what you're doing, yes.
Okay. We're going to take the leading term inside divided by the leading term outside. 5x squared divided by 5x would be x. We're going to write plus x up above there. Okay. We're going to take that x times the divisor, 5x minus 2, and we're going to get 5x squared minus 2x, which we'll write up here. Then we're going to subtract that quantity from what's up above. Distributing it, changing it to addition of the opposite. 5x squared plus negative 5x squared is 0x squared. 23x plus 2x is 25x. We'll bring down the next term, minus 10. Start all over. Leading term inside divided by leading term outside. 25x divided by 5x is 5. So we'll write plus 5. Then we'll take the 5 times the 5x minus 2, which gives us 25x minus 10, which we'll write there. Subtract that from what's up above, change it to addition of the opposite, and we get 0 remainder. So our final answer should be 3x squared plus x plus 5.
Yes, thank you.
You're welcome.
Somehow I got some signs wrong in it.
Yeah, it's tricky. It's easy to do. Anybody have any questions on this particular problem we just went through? All right, and then you wanted to look at problem number 8 on that same section. So this is 5.8, part 2, number 8. It says perform the division x cubed minus 1 over x minus 1. Okay. So on the outside, we've got x minus 1. On the inside, we've got x cubed minus 1. However, we've got some missing terms. So I'm going to rewrite it, x minus 1 on the outside and x cubed plus 0x squared plus 0x minus 1, filling in the missing powers. All righty. So now we'll take the leading term inside divided by the leading term outside. We get x cubed divided by x, which is x squared. That goes up here in the x squared column. Then we'll take x squared times the divisor, the x minus 1. Distributing, we get x cubed minus x squared. So x cubed minus x squared. We're going to subtract that quantity from what's up above. Distributing, changing it to addition of the opposite. X cubed plus negative x cubed is 0x cubed. 0x squared plus x squared is 1x squared. Bringing down the next term, plus 0x. Starting that whole process over, the inside leading term divided by the outside leading term, x squared divided by x is x, so plus x goes there. Then we take the x times the divisor, x minus 1, distributing, we get x squared minus x. X squared minus x goes there. We're going to subtract that quantity from what's up above. Distributing, changing it to addition of the opposite, x squared plus negative x squared is 0x squared. 0x plus x is x. Bring down the next term, the minus 1. Starting the whole process over, we'll divide the leading term inside by the leading term outside. X divided by x is 1, so we've got plus 1. We'll take that 1 times the divisor, so we get x minus 1, which we put there. We subtract. Distributing, changing it to addition of the opposite, and we get 0 remainder. So our answer is x squared plus x plus 1. All righty?
Thank you.
You're welcome. Anybody, any questions on this particular example? All right, what's next? Anybody have a specific question they want to look at? Okay, well then I will just kind of go through and highlight some things in each section. If you change your mind and have some questions, jump right in and let me know. I'm happy to entertain your questions. Okay, so this is section 5.4, and it was called polynomials. And the biggest mistake that students make involves the degree of a polynomial. So let's see here. Let's do this. Let's say we've got 3x to the 4th plus 7x cubed minus 2x plus 143. Okay. The first term of this polynomial, it has degree 4. The second term has degree 3. The third term has degree 1, right? Because there's an implied 1 exponent. And the fourth term has degree 0. Now that does not mean it's 143 to the 0 power. Again, the degree of a term is the sum of all the exponents on all the variables within that term, okay? Now, but the degree of the entire polynomial is equal to the degree of the highest powered term, which would be this. So this is a 4th degree polynomial, okay? I want to look at another example of this. Let's say we've got 4x squared y cubed minus 2xy squared plus 15z to the 6th power. Okay? So here we have a trinomial. The degree of the first term would be 5 because we've got 2 plus 3. Okay? The degree of the second term, my G looks like a J, would be what? 1, 2, 3. And the degree of the third term would be 6. Okay, so term by term, those are the degrees. Which of these terms has the highest degree? This one. So this is a 6th degree trinomial. Now, where people get mixed up, because we had to add these very exponents together to get the degree of the term, they carry that over and they say, well, the degree of the whole thing, they add up all the exponents, and that's not correct, okay? The degree of the polynomial is equal to the degree of the highest powered term within the polynomial, okay? Any questions on that? Like I say, that's one that people often miss. Let's see. We've got monomials have 1 term. Binomials have 2 terms. Trinomials have 3 terms. 4 terms or more, we just call them polynomials. And then in general, we group them all together, even including the monomials. We call them all polynomials, okay? Let's see here.
I have a question.
You bet. What?
Do I just tell you the problem?
Oh, is it? Sure. You bet.
Yeah. Okay, it's negative 4x squared divided by 16x to the power of 7.
Okay.
Yeah.
That's it?
Yeah.
Okay. So here we've got a single fraction and we're going to simplify it. And we need to have our final answer where the exponents are positive, but not negative. Okay. Now, negative 4 over 16 reduces down to negative 1 over 4. Okay. X squared over x to the 7th power, in other words, this part of the problem, would be x to the 2 minus 7 or x to the negative 5 power. But we're going to rewrite that as 1 over x to the 5th. So basically, this becomes 1 over x to the 5th. So now up on top, I've got negative 1 times 1. And on the bottom, I've got 4x to the 5th. And you could write it that way, or you could write it this way, putting the negative sign out in the front. We okay with that?
Oh, yeah.
But you wouldn't want to leave this up top and make it negative, because that's unless they tell you otherwise, you always make your exponents positive. There are some cases where they're negative, but that's specific cases. Scientific notation, among other things. All right, what else?
I thought I could write no negatives at all. That's why.
What's that?
I thought I couldn't write the negative sign at all.
Ah, okay, okay. I understand what you're talking about, and let me give you this problem. Okay. Now, let's just say we have this negative 4x to the negative 3 power. And let's say the directions say, rewrite this monomial using positive exponents only. Okay. Now, this is not an exponent. This is an exponent. There's nothing we can do to the negative 4 coefficient to make it positive. Okay. A common mistake is people write this. They think, oh, we'll just take that and move it downstairs and make it positive. That only applies to exponents, okay? Not to coefficients. So back here, this -1 is not an exponent, so we can't just move it downstairs and make it positive, okay? It only works with exponents. Does that make sense?
Yeah.
Okay, all right.
Yeah.
What else? Bring it on. Okay, well, while you're contemplating, I'm going to take a look at section 5.5, which was adding and subtracting polynomials. Okay. A couple of things. If you've got nothing in front of a grouping symbol or a plus sign in front of a grouping symbol, you just bring down what's in the grouping symbol. But if you have a subtraction sign in front, you have to distribute that subtraction sign, and it changes the sign of every term inside. I mean, here, technically, you're distributing the plus sign, but it doesn't change what's inside, okay? Multiplying by a negative changes the sign. Multiplying by a positive does not change the sign, okay? You need to be careful that you don't get combining like terms, which is adding and subtracting, confused with multiplying, okay? For instance, if I have 2x plus 2x, that is 4x. But if I have 2x times 2x, that's 4x squared. Or another example, let's say I have 2y plus 3y. That's 5y, but 2y times 3y is 6y squared. Okay, so again, be careful of the operations involved. Let's see, anything else I want to highlight in that section? And that's the main thing. And then multiplying polynomials 5.6, okay? So again, what I just talked about, multiplying is different from adding or subtracting. Let's see here. Just this whole idea of FOIL. Let's say you got 3x minus 4 times x plus 5. You take each term in the first binomial and multiply it by each term in the second binomial. So 3x squared plus 15x. And then you go on to the next term. So minus 4x minus 20, combining like terms, 3x squared plus 11x minus 20. Okay, that kind of idea. Any questions about the FOIL method? Something you want to be careful of. Okay, let's say we've got this situation. 4/9 a squared times 9a cubed plus a squared. All right, now, distributing, I would get 4/9 a squared times 9a cubed plus 4/9 a squared times a squared. And then here the 9s would reduce out and I'd get 4a to the 5th and then plus 4/9 a to the 4th. Let me clean that up a little bit better here. All right, and that's a correct way of doing it. Now, what students will do sometimes is they'll say, well, I don't want to bother writing that step. So they'll go in and they'll say, well, here, the 9s are going to reduce out and I'm going to get this. The problem is now they think that this 9 is no longer there and they just take 4a squared times a squared, okay? So if you're going to do this reducing in this step, do it in your head so that the 9 doesn't disappear there, okay? A safer way to go is to take this and write it like this, take this and write it like that. Then when you're reducing it, it's not going to affect this second product, okay? So again, that's a common mistake that I see, so be careful of that. Do you follow what I'm saying there? Is that confusing? Are you okay with that? I'll assume that means you're okay with that. Let's see here. And this came up kind of as the very first problem we did in that, or first or second one. If you've got, let's say, something like this, 2x plus 1, x minus 2. What you don't want to do is say, oh, we're going to take this times this times this, and this times this times this, and this times, it just, you can't do it. What you've got to do is only multiply together 2 things at a time. So if I'm going to do that first, I get the results, what, 8x squared plus 4x. Then I take that result times the next one, okay? You can't multiply all 3 things together at once. Even if you just have 2 times 3 times 5, you don't just look at it and say, oh, it's 30. How did I get that? Well, I went 2 times 3 is 6. 6 times 5 is 30. You don't go 2 times 3 and 2 times 5 kind of deal, okay? So again, just multiply 2 things together at a time. Let's see here. Ah, 5.7, special products. Can't spell worth a darn. The main thing I want to look at here is this idea. Let's see, you've got x plus 3 squared. That is not equal to x squared plus 3 squared or x squared plus 9. Okay, not true. If you have 3x, if you have a product raised to a power, then you attach that exponent to each factor inside, each factor, things being multiplied. But if you have a sum or a difference, you've got to expand it into 2 separate factors because it's a 2 as an exponent, and then what, FOIL it together. Or let's say you've got this cubed. That's not equal to x cubed plus 5 cubed. It's x plus 5 times x plus 5 times x plus 5. And here again, you're going to come back and just do 2 of them first, get the result, which is going to be what, x squared plus 10x plus 25, and take that times the final binomial. Okay, so that's another biggie where people tend to write this incorrectly. So watch out for that. Let's see. 5.8, dividing polynomials. Don't forget, let's see, if you're multiplying polynomials, or if you're multiplying powers with the same base, you add the exponents. If you're dividing, you subtract the bottom exponent from the top. Something raised to the 0 power is 1. If there's no exponent, that's implied something to the 1 power. When you're using long division of polynomials, what's inside has to be in descending powers. So let's say you had something like this, you'd want to rearrange it and write it like that before you start the division process. Also, if you have something like this, where you've got a missing power there, x squared, you need to fill that in.
I have a question.
You bet.
It's along the same lines as this
Sure. Okay, it's
we're
a
doing right now.
specific one. Sure. What do you got?
It was number 10 on the 5.8 second part.
Hang on here, number 10. So 5.8 part 2, number 10, and it says a cubed plus a divided by a plus 4. Is that the right one?
Yeah.
Okay. So outside, we're going to have a plus 4. Inside, we're going to have a cubed plus 0a squared plus a plus 0. So
That's what I was wondering, is if you put the 0 at the end or not.
yeah, and you know, I always put it there. Sometimes when you're doing the problems, they work out to where you don't need it. If you don't need it, it doesn't mess things up. But if you do need it, then if you don't have it there, it messes up your remainder. So I always just put it there and then kind of wait and see whether I need it. For this particular problem, I think I'm going to need it. Do you want me to do the problem, or was that your only question?
No, you can go ahead and do it.
Okay.
Because I never did get to the answer.
All right. So here we go. Leading term inside divided by leading term outside. A cubed divided by a is a squared. Then we take a squared times the divisor a plus 4, and we get a cubed plus 4a squared, which I write here. Okay. Going to draw a line, subtract that from what's up above, distribute, change it to addition of the opposite. A cubed plus negative a cubed is 0a cubed. 0a squared plus negative 4a squared is negative 4a squared. And then bring down the next term. Start the process over. Divide the leading term inside by the leading term outside. Negative 4a squared divided by a is negative 4a. So I get minus 4a. I'm going to take negative 4a times the a plus 4, which is negative 4a squared minus 16a. Negative 4a squared minus 16a. We're going to subtract that quantity from what's up above, but we're going to change it to addition of the opposite. Negative 4a squared plus 4a squared is 0a squared. A plus 16a is 17a. Or as they say in Canada, 17a. And then plus 0. Going to take the leading term inside divided by the leading term outside. 17a divided by a is 17, so plus 17. Then we're going to take the 17 times the a plus 4, which is 17a plus 68. So 17a plus 68. I'm going to subtract that from what's up above. I'm going to change it to addition of the opposite. 17a plus negative 17a is 0. 0 plus negative 68 is negative 68. Okay. So a squared minus 4a plus 17 plus negative 68 over a plus 4. Again, as I mentioned the other day, you could also write this answer like that, putting the subtraction sign outside of the fraction. Okay.
Thank you.
You're welcome. What
Can
else?
you just Oh, can you do one with the wooden handle?
One with a wooden
With
handle.
handle of the shovel? It says fx equals
Okay,
3x.
hang on. Let's get a picture of that. So who's asking here? Yesenia? Okay,
Me.
just a minute here. Let me
Oh,
find it. Let's see. Okay. Is this from the chapter review, or where are you getting it from?
chapter review.
Okay. Coming up here, the wooden handle, the shovel. So is this number 4?
Correct.
Okay, let's take a look there. So this problem right there. All right. Find a polynomial that represents the length of the wooden handle of the shovel. All right. Now, they give us the length of the entire shovel, the handle, and I can't remember if this is called the spade part or what it is, but the whole thing is f of x. Okay. So the whole thing is 3x squared plus x plus 1. That's the length of the entire thing. All right. The length of just the metal part is x squared minus 5. So if you know the whole thing and you know this part, how would you get the length of just the wooden handle? You'd take the entire length minus the metal piece. Does that make sense?
Oh, okay.
Is that yes? You're seeing it? Okay.
Yes.
All right. So my problem is going to look like that. I've got the entire length minus the metal piece. So that's 3x squared plus x plus 1 minus x squared. Minus times minus is plus 5, which is what? 2x squared plus x plus 6. And then the inches are the units. Okay. Does that make sense?
Yes, thank you.
All righty. What's next, folks? I've pretty much hit on the highlights that I wanted to do in terms of review. So all that's left now is any other questions you have. When we run out of questions, we'll send you on your merry way. But if you something else you want to look at, now is the time. All righty. Well, so you have until 11:59 tonight to finish up your chapter 5 test. Tomorrow, I'll be back again at 10 o'clock with an office hour, and then at 11 o'clock, and we'll start chapter 8. So good luck on your tests, and I will see you tomorrow.